So number 56 for multiple choice 3. The height of a rectangular box is 10 inches. Its length increases at the rate of 2 inches per second. Its width decreases at the rate of 4 inches per second. When the length is 8 and the width is 6, the rate at which the volume of the box is changing. Okay, so volume is length times width times height. It sounds like the height is set at 10. The length is increasing, so that means dl dt is positive 2. Its width, dw dt, is negative 4. When L is 8 and width is 6 and height is 10, because it already told us that, find the rate at which the volume of the box is changing. So find dv dt. Goodness, that's a lot of numbers in there to keep track of. So I need to take dv dt, knowing that what's changing? L is changing and W is changing. And maybe it'd be easier if I just wrote this as, since H is set at 10, 10 times L times W. Because the 10 isn't changing. So dv dt, this is a product rule. So one of them times the derivative of the other one, plus the other one times the derivative of the first one. And then it's just plug in all the pieces. 10 times 8 times negative 4 plus 10 times 6 times 2. Again, safe stop, one free response. Multiple choice, I don't have that option. So negative 320 plus 120. Again, they rig things so that the math, the algebra, the computations work out on the no calculator part of the test. If you're going crazy numbers, then you're probably doing something wrong.
Why did you put the 10 on the second?
So 10, you can, it depends on how you want to view it. You could just put the 10 out front of everybody. The 10's got to go to both of them. So if you want to view it as 10 times this and do that, or you could view it as 10 times L, or that would be, either view it as out front of everybody or attach it to one of them. It doesn't matter. You're going to end up with the same stuff. It's a constant. So maybe it would have been better to say it was 10L times W and find the derivative of that. But it still would have come out to be this. Negative 200. And spacing for AP test is way more spaced out than this. If you've taken one, you know that. Like, there's tons of room to work, to show your work. We're just trying to save paper. AP test charges you whatever it is, so they can afford all the paper and all the ink they want. So you're not going to get squished for space. You'll have plenty of room to work. So number 64, let the function with f of 0 equals 1 over pi squared, f of 2 equals 1 over pi squared, and derivative given by that function. Okay, that is the derivative, so I may not have to take a derivative. They're giving me one. How many values of x in the open interval 0 to 2 satisfy the conclusion of the mean value theorem on 0 to 2? Well, the mean value theorem says that the average rate of change equals the instantaneous rate of change. Provided that the function is continuous and differentiable. So average rate of change we can get from up here. That's just good old Algebra 1 stuff. In fact, that got real easy. That was 0. You may not remember it, but that's Rolle's theorem is the special case of MBT. So this is actually Rolle's theorem, but they don't call it that. They call it MBT, which is accurate. It's just the special case of MBT. So we want to know where 0 equals the instantaneous rate of change, but that's the derivative, and they gave us the derivative. So how many values of x in the open interval? How many values of x in the open interval? Oh, this is tricky. So I don't want to include 0 and 2. Satisfy the MBT for the function f on the closed interval. Well, it says how many values of x in the open interval. So 0 is not allowed, even though 0 would work right here. So let's set both of those things equal to 0. Right, set both factors equal to 0. X equals 0 is outside the interval, so I can't use that. That one's tricky because it's the open versus closed thing that throws it out. But they didn't make us memorize which one we had to use. They told us how many values in the open interval. So can't use 0. All right, cosine pi x equals 0. That would mean pi x needs to be, let's see, where's cosine equal to 0? At pi over 2 and 3 pi over 2, 5 pi over 2 if we kept going, and 7 pi over 2. And we divide all those by pi. We get 1/2 and 3/2, 5/2 and 7/2 and so on. But we only want from 0 to 2, so we can throw out 5/2 and 7/2 and anything beyond that. So 2 places. That was kind of a tricky one. But the big thing for MVT is that algebra slope equals calculus slope.